In this video, we will show you how to interpret a study download and a guide to the variable column headers. Data downloads are in the wide format, and here you can see a preview. They're in the wide format where each row represents a single subject denoted by a unique human ID. Here is the data in the wide format, and the variables are usually listed in alphabetical order, so the unique human ID will be here. Variable column headers follow a consistent naming convention to provide metadata about the data within each column. These headers describe details such as the subject, the measurement, and the time of the data collection. Here we have some examples that illustrate how column headers may differ depending on the variable being described. So here you can see that we have a category of variables without a study visit. These are time invariant variables and are listed only using the entity and attribute. The entity is a person, place, or object that exists, and the subject or object the variable describes. Some examples are like a caregiver human, child anatomy, pregnancy sample, or mother household sample. The attribute is a characteristic of an entity, the specific variable being described. Some examples are biological sex, height, and smoking status. So in this example up here, variables without study visit, we have caregiver human, biological sex. So this is where the first name here describes the entity, and the second is the attribute, which for here we have biological sex. In our next examples, we have variables that include a study visit. So these are time-varying variables, including a study visit or a time period tagged to clarify the collection period. For example, study visits could be birth, first trimester, childhood period, or adolescent baseline. In these naming conventions, we first name the entity, then the attribute, then the study visit or associated time period. So in the examples we have here, we have the entity, the child human, the attribute is the height Z-score, and it was taken during childhood baseline. In our second example, we have our entity as a caregiver human. The attribute is the smoking status, so that's the smoking status of the caregiver human, and this was taken during a childhood follow-up. That's the study visit. For our third set of examples, these are variables showing continuous measurements. Continuous variables often specify the unit of measurement, except for unitless values like z-scores or specific gravity. So here we usually name the entity first, then the attribute, then the unit of measurement for the attribute, and finally the study visit or associated time period. So in our examples here, first we have our entity human. Our attribute is the z-score, body mass index, BMI. So that is the attribute of the child human. And then this was taken during an adolescent period. This does not have a unit, so no unit is specified. In our next example, we have our entity child human. Our attribute is body weight. The unit of body weight is kilograms, and the study visit where this was taken was during birth. In our last example, we have our entity child anatomy, the attribute head circumference. The unit that this was measured in was in centimeters, and the study visit where this was taken was during birth. In our next examples, we have lab sample variables. Lab variables include additional details such as the matrix, measurement, analyte, unit, and study visit. The matrix is defined as a substance or material where measurements or analyses are conducted. Some examples include blood, urine, plasma, saliva, or a water sample. A measurement, this is a type of measure taken of the analyte in the matrix. Some examples are specific gravity, mean concentration, or limit of detection. And the analyte is the chemical or biological entity being analyzed, which may include the name, the full name, and abbreviation of the analyte. And some examples are cotinine, leptin, or lead. Here we first name the entity, then the attribute, then the matrix, then the measurement, the analyte, then the unit of measurement, and finally the study visit or the time period. So in our examples here, in this first example, we have the entity is the child sample, the matrix in which it was taken was urine, the measurement is specific gravity, which is unitless, and then we have the study visit, which is childhood period. In our next example, we have the entity, which is a child sample. The matrix it was taken is cord blood. The measurement of the analyte is concentration. The specific analyte is arsenic V acid. The unit of the analyte is in micrograms per deciliter, and the study visit where this was taken was during birth. Here in our next example, we have our entity, which is pregnancy sample. The matrix of the pregnancy sample is urine. The measurement that this will be is the limit of detection. This is the limit of detection of arsenic, which is our analyte. The unit of analysis was nanograms per milliliter, and the study visit where this took place was during the third trimester. In our last example for this, we have the entity is a child sample, the matrix is urine, the specific measurement it will be is the concentration, and the analyte of the concentration is monoisobutyl phthalate, the abbreviation DIBP. The unit this was measured in was micrograms per liter, and the study visit is childhood period. The last set of samples are derived lab samples, which are also environmental sample variables. They follow a similar format, adding context for the matrix and the unit of measurement. And here again, we usually have the entity, then the attribute, the matrix, the measurement, the analyte, unit of measurement, and finally a study visit or time period. In this last example, the entity is mother household sample. The matrix is drinking water. The measurement is concentration, so it's a concentration of the analyte arsenic in the drinking water. The unit this was measured in was in microliters, and the time period this took place is during pregnancy. We have this structure to ensure consistency and clarity when working with HEAR datasets, and this allows users to efficiently decode variable meanings and understand their context of the data.